Good morning, everyone. Welcome to you all for today's very interesting webinar on the topic of geosciences. It is very aptly titled as Geosciences for Life, not just for marks. This week is a very interesting week because 17th of November was celebrated as World GIS Day. So in today's webinar, we have got very eminent speakers who are going to give you a gist of what geoscience is all about. Before we dwell into the presentations of our speakers, let's just have a quick video to introduce you all about what is IEEE, what is IEEE Geoscience and Remote Sensing Society.
GRSS
is the IEEE
Geoscience
and Remote Sensing Society.
Our mission is to build a community of researchers and practitioners by means of knowledge sharing and scientifically rigorous dissemination of the latest advancement in remote sensing.
The technical committees are really meant for doing the technical outreach to other parts of the research community and industry.
We want to inform our members and reach different communities via different channels, like for example social media, journal, and especially education.
At the moment we have more than 60 chapters and 20 student branches all over the world.
I love GIS family very much and I'm very honored to be the member of it.
Being part of GRSS allows me to be a better researcher and professional, improving my skills and knowledge to do a good job. Come and be part of this great family. Ciao!
I believe all of you had a very quick overview on what is Geoscience and Remote Sensing Society. It is a society affiliated with IEEE, which is International Institute of Electrical and Electronics Engineers. It is one of the world's biggest professional organizations, which has more than 4.5 lakh members across the globe. Geoscience and Remote Sensing Society is affiliated with IEEE, and it is focused more on the area of geoscience and remote sensing domain. You'll get to know more about what geoscience is, what remote sensing is, and how it is very critical in our day-to-day lives. That is the core idea of today's webinar. Before we get into the event, I'll just give you a very quick introduction about the speakers we have lined up today. During their presentations, they will also give a more detailed overview on their profession. First, we have got Dr. Chandra Shekhar Balachandran. Dr. Chandra Shekhar Balachandran is a geographer with over 30 years of experience in teaching geography, right from K-12 students all the way to postgraduate students. He has got experience of teaching students in U.S.A. He has taught students in India. Right now, he is based out of Mysore, and he is more involved in innovative methods of teaching geography for school children. You should listen more about his talk, and you will get a very good idea on how interesting and how exciting the subject of geography and geosciences are. We also have with us Mr. Nagajothi Kannan. He is a scientist from ISRO. ISRO is a short form for Indian Space Research Organization. And he will also be talking to you more about remote sensing domain, and also what is the contribution of ISRO in terms of remote sensing and all these aspects. Lastly, we have got Mr. Ujaval Gandhi. Mr. Ujaval Gandhi is a well-known name when it comes to learning of GIS technology across the globe. Ujaval has worked in Google company for more than a decade, and just recently he has come out of Google and started his own venture, Spatial Thoughts, and he is involved in training people across the globe in the field of GIS, especially on the open source software. So when Ujaval is presenting, you'll get to know more about how different tools will be used to do geographic analysis, remote sensing analysis. So this is a very quick overview of all the people who are speaking today. Before I pass it on to Dr. Chandra Shekhar Balachandran, I just want to do a bit of housekeeping. You would have a window in the bottom of your screen with Q&A. So if you have any questions, you can post it in the Q&A. If in case you want to ask your question orally, that is, you want to talk to the speakers of today's webinar, you can use the raise hand symbol in the bottom. So the webinar admin will unmute you and you can post your questions. Towards the end of the webinar, we'll also be sharing a feedback forum link. You can access the link and give your feedback about today's webinar, and there will be few other inputs we want to collect from you, so that we want to create more and more such webinars so that it benefits all of you. So that's it from me. Over to you, Dr. Balachandran, sir.
Thank you very much, Mr. Gurudatta. Good morning, everyone. I don't know who are all there, but whoever is there, good morning to all of you. My job today will be to basically give you a background about geoscience and what I have found as a geographer, how I find it in various things around me in my world, and how it helps me make connections. After that, Mr. Ujaval Gandhi will show you how to actually go about using technologies that are amazing technologies that are available to us, with which you can actually look at some of the connections among the things in the world. And finally, Mr. Nagajothi will talk about ISRO's contribution to all of this, because ISRO is the big player in terms of sending out satellites with which we are able to look at Earth and do a variety of things that are of benefit to us. So basically about myself, I'm a native of Bangalore, where I studied and then went off to the US for further studies, taught in the US for about 20 years, came back to Bangalore, returned to India in 2000. And I continued to do work in geography education and continued to do that through the Institute of Geographical Studies, which I established in Bangalore. So for me, everything is geography. I live geography. So when somebody asks me what is geography, they really get to hear it. So geoscience stories and how it helps humanity. I'll give you two examples of doctors. One is a medical doctor in 1854 by the name of Dr. John Snow in London. In 1854, there was an outbreak of cholera in London. And the disease started spreading phenomenally quickly. What do you do? Up and down, all these things. And then John Snow had this idea of taking a map and plotting all the places where cholera was breaking out. And he noticed that the largest concentration of cases was around one particular bore well pump, the kind that we used to have in India also, where you pump with your hand. And he said, turn that pump off. So they turned the pump off, which meant immediately after that, they saw their decline in the number of cholera cases there. And so from this, he deduced that there is something in the water that's not right, that's causing the cholera to spread. And then they found out that there was a problem with the water supply, because the water supply and the sewage system were too close, and the sewage system was polluting the water supply. So that is one of the earliest examples we are often told of the application of geography, geoscience, to understanding and solving a human problem. Then fast forward to 2015, when there was a massive earthquake in Nepal. Lots of people around the world wanted to help the Nepali population by giving them aid and all sorts of things. But the problem was, once you got all the materials and people to Kathmandu, the capital of Nepal, after that, nobody knew where to go. If you don't know where to go and how, then you cannot decide how to give aid to people. So I have a friend who's a doctor who organized a group of people to go and set up health camps for people to give them medical support and psychological support. Mental health is also an issue. But the problem was, where should he set up the medical camps? This was a big issue. But not to worry, throughout the world, people who are working with digital maps and data, they just formed an international community within hours. There were people who are producing maps and sharing it openly online. And my friend and his team were able to find out where would be the best location for them to set up their health camps. because they had to figure out a place where people could actually move. It could not be too far high, because then people have to climb. If they're injured, they can't climb. So all sorts of factors went into it. All of this ultimately came down to be a geography issue. So maps helped. Until then, the government of Nepal did not have any maps to give people. It was this international community of volunteers who were so passionate about geoscience and its application. They came together and provided this map. And I have given links in all of these things that you can later on look at the slideshow, click on those links and go to the original material I'm talking about. They have found that satellites are a great help in trying to help economic development in Africa. So there are parts of Africa where houses are very far apart. Communities are very small. So for people to go physically, go from house to house and ask questions and gather data, it would be very time consuming and it would cost a lot of money. So they figured out a way of using satellites to capture certain kinds of information. Based on that kind of information, they could decide which areas needed what kind of help and then get the help directly to those areas, thus saving a lot of money, which can now go into providing the service rather than simply spending money on people going from place to place. So here was again an issue where place was the key. And to understand place, we had to use these technologies very innovatively to come up with solutions to these problems. And more recently, you might have heard about this in COVID care in India. Lots of people developed apps very quickly. And somebody wants oxygen cylinders. They went on WhatsApp to some group or the other. They posted a request saying, I live in Mysore or Bangalore or wherever. I need 2 oxygen cylinders for somebody who's COVID positive. And within a matter of minutes, usually, there will be information given to them exactly where to get it, how to get it, what it would cost, everything. So all of these things were made possible because of what we call cyberspace. Part of that cyberspace are satellites and these technologies which connect places regardless of physical boundaries or political boundaries. So COVID care in India benefited enormously from satellite technology and mobile phone technology, which is in turn connected to satellite technology. Understanding extreme stress weather events, we call them natural disasters. I don't believe in that concept of natural disasters. I prefer to use extreme stress events. In this case, weather, lately you will have noticed in the news, phenomenal amounts of rain, flooding. Just yesterday, there was footage floating around of how Tirupati is getting flooded on the hillsides. So people are being told not to come to Tirupati right now in southern India. So in all of these things, we have geoscience making a huge impact in helping people. So geoscience has 4 fundamental questions it asks. First of all, it's a question of location. Where is something? So if you're talking about the floods, where are the floods happening? If you're talking about COVID, where are the COVID cases occurring? If you're talking about smog, which is a combination of fog and smoke coming from a lot of pollution, where is the smog occurring? All of these things are where questions. Location, because place matters. The second question is, why is it there? And I'll show you later on, I'll show you a brief image of the smog in Delhi and the causes of the smog and where the smog is coming from. The consequences are very, very bad for the people who are living in Delhi. Health issues, schools have been shut down. All schools have been shut down in Delhi indefinitely. So it has very real implications for human life on Earth. So why is it there? Once we understand why something is where it is, then we can begin to address the problem. So when we looked at COVID, we asked, why is COVID there, but not here? And then we started looking at what the causes might be. And then we saw people were moving around. And then we started contact tracing and so on and so forth. And specific areas were locked down. So the people in that area were confined to that place so that they would not spread the disease elsewhere. So once you understand why it is there, we have to so what is the consequence of it being there? The consequence of the smog being in Delhi is that life in Delhi is come to almost a complete stop because of lockdown caused by smog. Right now, schools are closed, as I told you. So there are implications, there are results, there are impacts of what is going on in any place. And oftentimes the impact are not just local, they spread farther from there. Then the fourth question is, what if we change something? So the response to COVID spreading was the lockdown idea. Basically confine geographically sensitive areas, keep people there, not let them move around, and deliver services there. So in that process also, the COVID care apps, such as Arogya Setu, made a huge difference. So these four questions of geoscience, geography, they offer a wonderful framework with which to approach the world and its issues. Today, as we listen to Ujaval Gandhi's presentation and Nagajothi sir's presentation, keep these four questions in mind and look at how that framework is in operation in everything they are describing. It's geography because place matters. So, understanding natural sciences in a geographical context and using it to help the planet. That is geosciences in a nutshell. And if you look at some of the examples, so you look at the climatic patterns around the world, you see physics, chemistry, biology, mathematics, all these natural sciences, plus geography. And how is it all coming together with the help of technology, the kind of which that Mr. Ujaval Gandhi and Mr. Nagajothi are going to talk about today. Patterns of agriculture. Again, you look at physics, chemistry, mathematics, and all of these, but then you also have to look at anthropology, economics, geography, because people live somewhere and they make decisions based on a variety of factors, including self-interest. But how do we understand these patterns of agriculture and how can we best help farmers, for example? Patterns of COVID-19, for which you need to understand every one of those disciplines I've listed there, they're all actually collection of other disciplines too. Epidemiology, biology, ecology, physics, you name it. But ultimately, you also end up coming to geography because place matters. Where are fossil fuels distributed? Which helps us understand the politics, international geopolitics of countries which produce oil and countries which consume oil, and how those interactions influence foreign policy, and how does that foreign policy affect people living in those countries. So place matters. So here we look at the latest wind movements. And you can see there's a lot of circulation going on here, which is bringing moisture from the Bay of Bengal onto southeastern India and further interior. So Mysore, where I live, has been having phenomenal amount of rain for the past 3 weeks or 4 weeks almost. Part of it is coming from this system. Yeah? Those of you living in Bangalore also would be able to relate to this process that's going on. So we look at ocean circulation here. Let me see if I can play this. Yeah.
Driven by winds.
Yeah. So when you look at ocean
below the surface,
circulation,
however, currents are controlled by water density.
When you look at ocean currents, you understand why it is important for us to care about the environment, because if this oceanic movement stops or gets disrupted too badly, our climatic patterns will go completely for a 6. And when the climatic patterns go for a 6, we're all in trouble. All the living things are in trouble, not just human beings. I also want you to look at another video online. Here again, I'll shut the sound off. This is a video by NASA talking about how things are interconnected on Earth. So if ever you get to the point where you think that is happening somewhere there, why should I care? You should care because it is going to affect you as well. Why? Place matters. That's the ultimate mantra for you to remember. Okay, and then you look at how things are changing here. The Kosi River in Bihar, how it keeps changing its course. See that? I'll play it again. It keeps wandering. So if you're living on the banks of the Kosi River, this has very real impact for you. Your life and your livelihood could be affected by this kind of movement. Okay, so I'll end with that note, basically asking you to remember that place matters. In anything, place matters. How does place matter? Why does place matter? What is the impact of place mattering? And what can you learn about it? What can you do about it? And if you understand this process and look at geoscience, then it becomes much more interesting, not what you find in the textbook. You have to start questioning things along the lines that we are talking about here today. And then once you do that, you will find that, gosh, this is so fascinating. I'm very good with computers. I can do this. I'm very good with writing. I can combine that with my knowledge of geoscience and produce some new knowledge. These kinds of things become possible. So don't think only in terms of getting a job at ISRO, getting a job at someplace else. That is very narrow. Open your minds out to much wider possibilities. The world is waiting for you. And if you are a good geoscientist, the world will welcome you with open arms. There is nothing to stop you but your imagination. So now I'll now hand over to Mr. Ujjwal Gandhi, founder of Spatial Thoughts. He's going to take us through some amazingly fascinating stories, really, and show us how we can use geoscience to make sense of our world. Mr. Gandhi?
Thank you. Thank you, Dr. Balachandran, for this great overview, welcoming all the participants today. I'm going to talk to you about build on what Dr. Balachandran said and show you how you can kind of explore the world around you and make sense of it. I'm not going to bore you with any presentation or slides. I just have a few slides and I'm going to show you some stories and tell you some stories about how curiosity about our natural world and the urge to understand what's going on has helped me in my career and how it can help you too. So we'll start with just a few slides and then we'll dive into some of those demos. And I would love to take questions during the talk, so please feel free to type it in, whatever questions you might have. And I like the theme for today is the geoscience for everyone and geoscience for life. And this is the theme of the talk today, how you can make your life better, the life of people around you better using geoscience. A bit of background about me. When I was in high school, I had no idea what I wanted to be. Just like many of you, I became a civil engineer because that's what my parents thought would be best for me. But as I was kind of doing my studies, I got this internship at this place called Indian Institute of Remote Sensing. And happened by chance. I chose this place because it was close to Mussoorie and we thought we'll spend a nice summer hanging out in Mussoorie. But when I ended up there, I just got to experience this amazing world of remote sensing and satellites and totally got fascinated. And I spent the summer learning everything I could about this world. And I came back to college and said, this is what I want to do. So I went to do my master's in geoscience from University of Wisconsin, Madison. And as I was finishing my master's, I was doing some odd jobs here and there, and I got my break where I got my first real job at Google. And this was very early days of Google. Google had just acquired this company called Keyhole, which was making this 3D viewer for satellite images. And I got to kind of be there at that time and see how Google Earth and Google Maps got built. And I came to India later on to be part of the team that built the Google Maps for India. And this was the early days. I used to get angry phone calls from my friends whenever they got lost using Google Maps, and they knew whom to call to get these issues fixed. We've come a long way from that. But again, you know, I could see the journey of how to build a system like that. And I was always interested in education training. I did a lot of that at Google, and recently I have my own startup where I'm trying to help people understand this world of geoscience and apply those modern technologies. Today I'm going to focus on some stories from my life, from my high school days, and how geography looked like then and how the geosciences look now. And in school, geography, history, civics, and what you would call EVS was the least favorite of my subjects, because they were taught using a method that was not very interesting for people. So I'm going to show some examples of how we learned and how you can learn this technique. But before that, I'm going to show some of the tools that might be useful to you. We're going to be spending a lot of time in this tool called Google Earth. It's a free app. And you can use it on your computer, you can use it on your mobile phone. If you have Android phone, iOS, iPhone, or iPad, this is one app that you would not regret having. And this is allows you to explore everything that we're going to show you today, plus a lot more. So after the talk, do try this out. The best experience to kind of have a feeling of Earth in your hand is an iPad. So if you do have an iPad, do try and install this app and use that. So let's see what Google Earth looks like. You can go to earth.google.com, and this is what you see. This is the entire globe in high resolution images available in your browser. And as you end up in Google Earth, you see a screen like this. And this is basically the world that it looks like now. And these are the real-time clouds. And you can see where are the clouds right now in the world. And you have the access to everything in the world. This is a 3D viewer. I can just go and search for something. So let's go to Eiffel Tower to start. Right? And this is one of the most viewed places in Google Earth. Everybody wants to look at Eiffel Tower. And here we are in Eiffel Tower. You can see the Paris in full 3D view. You can see the real Eiffel Tower. And it's not only like a video where you can just see, you can explore and interact with it. You can see how does Paris look like, how is Paris different from where you live. If you want to look at, say, how tall is the Eiffel Tower, and you can look up and see things. And this is available everywhere in the world. Think of any place in the world you want, and you can go there. But what do most people do when you have a system like this where you can go anywhere and see anything from space? Well, you go to your home. This is what I did for the first time, even when I discovered Google Earth. Though I've studied geosciences all my life, when I first came this, I wanted to see my home. So let's look at home. You can go and search. I live and grew up in Ahmedabad, and I wanted to see how Ahmedabad looks from space. So let's just fly to Ahmedabad. And you end up here, you can learn a little bit more information about the place, but you can zoom in and learn more about it. I live on the west part of Ahmedabad. And again, we have a beautiful river, Sabarmati, passing through the city. This is one of the key highlights of the city. Nowadays I cycle and go to the riverfront here, and there's a nice cycling and jogging track. I can just zoom in as much as I want and see this world in very high detail. So now you can go to any place in the world, look at it, you know what the places are, how they look, and keep exploring this place. So as you're exploring, this is an amazing platform. It's easy to get lost and spend hours and hours there. So as you're going around this Sabarmati River, one of the places that you might be interested is the Sabarmati Ashram. This is one of the most popular landmarks in Ahmedabad. And this is where Mahatma Gandhi built his movement from. So if you say, I want to visit Sabarmati Ashram and I want to look at how it looks, you can see it from space, but again, it just tells you how it looks from above. If you want to know more, Google Earth has this really interesting feature where you can go in and see what's inside. So you see this little icon which says, it's a little pegman here. You can drag this button, and wherever you see blue, this is where you have street level imagery. And across the world, you have many places which are covered in this detail. So let's go to the Gandhi Ashram. And here you are in Gandhi Ashram. You have a 360 imagery. This is where you come in and you see this beautiful ashram, and you have 360 imagery. And now you can experience this place virtually if you want to understand more. You don't have to come to Ahmedabad and see it, but if you do visit this place, this is one of my favorite places to be. Really peaceful. You can really feel the energy when you come to this place. And you can click around and visit there. If you want to see the museum, you can actually go inside the museum and explore all the exhibit. Most of the museums of the world are now online, and you can go anywhere in the museum and see all the artwork, see all the exhibits, and go around and explore this. It's an amazing resource, and you can learn more about it. One of the things I used to do when I visit a museum, I used to take photos of this and say, I'll come and read at home. I don't do that anymore because I can now always go here and find all the exhibits in the museums. If you want to explore the ashram, you can explore it here. I'll show you the riverfront here. This is one of the nice places to come and visit and explore this area. So this is the Sabarmati riverfront, and you can see it captured in the 3D view here. And you can also visit the home of Mahatma Gandhi. This was the home where Mahatma Gandhi used to live and built his movement. Right? So again, the idea is all of this is at your fingertips. You can explore your hometown, you can explore the world and see those in life. So now what? Now you've done this, most people, they see the home, explore, but how can you kind of apply this and learn more about the world around you? So let's show you some examples. So one of my earliest memories or nightmares from my geography class was a teacher giving out a blank map of India and saying, draw all the rivers. And this was also part of the exam. This is from one of the textbooks that I picked up this map from. And again, drawing rivers on a blank map is useful, but it doesn't help you understand. I was very good at, so I could actually remember whether the rivers were, draw it, get good marks, but it didn't help me understand that. And you might be also had a similar experience to have drawn this map. But now, if you are in the 21st century, you want to learn about the river systems. Let's see how you can learn this in a much better way. If you are a teacher, how can you leverage these platforms like Google Earth to teach better? And if you're just curious about rivers, how can you use that? So I'll show you that next. There's a question about in the Q&A about, does Google Earth show real-time images? No, the Google Earth images are not real-time. They are captured, and you can see, as you zoom in, you'll see the image here. So this is taken in March or I think October. So this is 3/10/21. So again, they're at least delayed by a few weeks because it takes time to capture and process those images. So it depends on where you are. Images are anywhere from few months to few years old. One of the features that is really useful in Google Earth is this tool called Voyager. So if I click on this icon that shows Voyager, you have this resource here. It's divided into different sections. You can even play geography games if you want. You can explore different themes. But if you come under education, this is where you will find a lot of content that you might be able to relate from your textbooks as you're studying and learning about geography. If you're a teacher, they can also use this to teach in the class. So let's learn about some rivers. So here we have a story on the rivers of India. This is done by an organization called India Literacy Project. And they actually took the curriculum of the high school class 5, 6, 7, and now they teach in a lot of government schools using Google Earth and using such kind of content. And as you'll see, this is much better way where you can learn, explore, inspire curiosity than a paper map where you need to draw rivers. So let's learn about Ganga. This is the most important river in India, both religiously as well as for our country, resource. And you can learn a bit about the river, what it's about. You can see this map, but most importantly, you can now explore. So we were taught that Ganga originates from Gangotri Glacier. I had never seen a glacier ever in my life as I was studying. I didn't know what a glacier looked like, but now you can. You can go to Gangotri Glacier and see this is the place. This is Gangotri Glacier. You can see this world in 3D, explore the place around, see this is what the glaciers look like. And now you can see what happens if you read in news, the glaciers are melting, the glaciers are retreating. What does it mean and how this would affect? So now let's follow the river. Today, the story I'm going to tell you is the story of River Ganga. And let's just follow this river and see if we can find things along the way. So here I can go and follow this river. And as I'm going around the river, the first thing you'll notice that this river is called Bhagirathi. It's not Ganga. But we were taught that Ganga originates from Gangotri Glacier. So what's going on? Well, the river that originates from Gangotri is named Bhagirathi and becomes Ganga much later on. So let's go around Bhagirathi River and you can kind of see the path of the river, but most importantly, you can see the places around it. And again, you can't understand geography without understanding the context around it. So to understand Ganga, you should understand what's around it. And this is the human geography. This is how river Ganga is significant. And you can see a lot of religious places, temples along the way. And you can explore that as you go around. If you find a lot of interesting places, you can go in and again, explore that in the 3D surround view that we talked about earlier. So let's keep going around the river. And again, you can spend hours and hours exploring this. At Google, we had a saying that Google Maps is to find your way and Google Earth is to get lost. When you want to get lost, you come to Google Earth and you come here. So this is the place and you can kind of see how the river goes around. Let's keep going. And as we keep going around, the first stop will come here is this place called Tehri Dam. And dams always fascinated me as I was growing up. And again, I saw a few reservoirs, but I didn't really understand what's going on here. And now, if you see this dam, you can see that this river now becomes a reservoir because you have blocked the flow of the river. The Tehri Dam is also the highest dam in India. So you can see now this is the dam, and it's created a reservoir building it. This was also one of the most controversial dams as it got built. And if you want to see what happened, you have access to historic imagery as well. So there's a tool that's available called Google Earth Time Lapse, which allows you to explore the world as it was in the past and as well as in the present. This is using NASA satellites that are capturing data since 1980s, and you have the continuous record of the Earth through those years. So let's go, you can go anywhere in the world. I've searched Tehri Dam, I've come here, and this is 1984. You can see this was the river Bhagirathi in 1984. There was no dam there. And the dam construction started, and you can kind of go around the timeline and see in 1990s, you can see now the dam construction is going on. And as you kind of move forward, you'll suddenly see that the dam construction finished in over time. And again, it got delayed by a long time. Over time, the dam opened finally in 2005. And you can see in 2006, it created this reservoir. And there was concerns about a lot of environmental impacts, people, homes getting flooded due to the dam, etc. And now you can see that history, and you can kind of go back and see what happened. So this is a great tool to see where what happened in the past and how it landed up in the current. So we keep going, and we keep going further down the river, and then we come to this place called Devprayag. And this is what is called a Sangam. And you might have, when visited this place, it's a very important place for Hindu religion. And because this is where the two rivers, this is the river Alaknanda, and this is the river Bhagirathi, they meet together and they form Ganga. And now you can see the confluence where the two rivers are actually distinct rivers merging together. They are in different colors here, and they merge together to form Ganga. If you want to explore more, you can again take this icon and I can drop it on this, and I can dive in and see the 360-degree view of this place. And now you can see this is the Sangam, and this is a photo of those two rivers merging. Fascinating view. You can now visit this from your phone and see those amazing view, and you can understand this geography much better. All right, so I hope this gives you some inspiration about exploring. Do try out Google Earth and explore the content that are in the education section. It will really help you understand and explore things much better. All right, I'll tell you another story from my childhood. When I was in about 8th grade, we were on a vacation. We had Diwali holidays, and we had gone on a trip to Rajasthan. And of course, I was the map nerd in the family, so I was sitting at the back with the atlas in the back, trying to help navigate. And if many of you may not have even seen atlas, but this was printed maps in a book where you have highway sections broken into multiple pages, and you kind of navigate with landmarks. And as I was an 8th grader navigating, obviously is wrong things bound to happen. So we got lost in the desert, and we were trying to find our way back, asking people around. And turned out some of the locals said that, hey, there's a solar eclipse happening today. And we had no idea it's going to happen. And said, yeah, you can see it from here. And we got to see the solar eclipse, one of the fascinating memories from my childhood. And we saw the solar eclipse. It was an amazing sight. The solar eclipse happens when the moon comes between Earth and sun, and the sun gets blocked completely. This was the first time experiencing where you suddenly see, as the moon blocks the view of the sun, everything goes dark, the temperature drops. We could see the birds changing their path. They thought it was night, and suddenly they would start flying the other way. So it's an amazing experience. I got really curious, and it's like, I came back home and I was talking to other people. I said, did you see the eclipse? Said, no, we did not. Or we didn't experience it in the full way. And I was like, why could we see the eclipse from where we were, and why not here? And why it lasted only a few seconds? So again, that led me to kind of explore more about astronomy and how the planets interact with each other. Nowadays, you have this amazing resources. So if I look at the eclipse, this was 95. And you have the data available. If you search for solar eclipse 95, you'll end up on a page like this. And this page shows you where the path of the eclipse. This is where the path of the moon was in relation to the Earth. And this is where the line in the center was the place where the total eclipse happened. And it so happened that we were in a place in Rajasthan, which happened to be right here. And we could experience that complete solar eclipse during that time. And if you were somewhere here, you would not see that. Right? So this was by chance we witnessed this amazing event. Now you can do a lot of this in Google Earth. So I'm going to show you. You have tools in Google Earth to track eclipse, explore what happens, and see this in much more detail. So this is a story in Google Earth about the 2017 eclipse that was you could see over the United States. And you could see this is the path of the eclipse. And if you are planning nowadays, you have that information, if you're planning to go and see this, you can see where you would want to go to see those eclipses in more detail. So for example, if you are in New York, you can see this is the shadow of the moon at this particular time. So if you can see the time, you can see at this time, this is where the shadow would be, and you can see where you need to be at each of those times to see that in context, and you can plan your trip around that. And you can also understand how the path of the moon moves and how the earth movement affects where you could see the solar eclipse. And this is a photo of a nerdy 8th grader, very happy after seeing the solar eclipse. I had my mom dig up this photo from the archive. So this was the place after we saw the solar eclipse. But now you have those tools at your place that will allow you to explore this phenomena in much more detail. All right, so now once it's great to explore, it's the first step in understanding the world. Once you explore, without exploration, you cannot understand the world. So once you explored, you saw what's going around. Now, how do you understand? How do you relate multiple things and see those in action? And I want to show you a few examples of that. This is one of my favorite stories that combines mythology, science together into this amazing visualization. So this is put together by M.T. Madhusudan. He is a great scientist who works at Nature, who founded Nature Conservation Foundation. And he had this question where there is a mythology about this bird. This is the Chataka bird that is described in the mythology. And the legend says that this bird heralds the arrival of monsoon, where this bird never drinks water from the ground, it only drinks water from the clouds. And whenever you see Chatak bird, that means monsoon is coming. And he wanted to see, is that true? Is that legend kind of checks out with the modern scientific evidence? So he started on this journey where you can see we have all the data. This is the Indian monsoon. You have satellites and ground measurements tracking how the rainfall and monsoon progresses. And he said, can we use that to see if we can correlate the movement of Chatak bird with the rainfall? So he used this database called eBird. This is an app where all the amateur and professional bird watchers, they can, whenever they see a bird, they can take a photo, record the location, and it's a huge database of all the bird sightings. So he just extracted the sightings of Chatak birds that were taken over the years, and it says, I know where the Chatak bird appears at different times, and can I see where it appears as the monsoon progresses? So you can see the bird is predominantly lives in the south of India throughout the year, and as you see that the monsoon progresses, the birds, there are more sightings of the bird as it moves north. So you can see now the monsoon progressing, and the sightings of Chatak bird also moving north. And you can, if you look closely, you will see that the Chatak bird is always ahead of the monsoon front. That means whenever you see a Chatak bird, then the monsoon is close by. So now using the data from citizen scientists, using the data from the satellite precipitation measurements, you were able to create this measurements. And you can kind of see this in much more detail, read about the story, and do this kind of thing. So again, this is a great example of using science, using geoscience to understand your world. And if you have this curiosity, you have the data and the technology to be able to do this. I want to show about another kind of analysis or exploration that you could do. This is right now we are experiencing climate change, we are experiencing rapid urbanization across the world. One of the main issues that is causing is rise of temperatures. And there's a phenomena known as urban heat island. The phenomena is basically that the surfaces, urban surfaces, roads, buildings, they tend to heat up much more, and they tend to capture heat much more than the green surfaces. And that's why if you have experienced this, where you're in the city, you start driving out, as you go towards more greener suburbs, the temperature suddenly drops and those are much cooler. So this phenomenon is known as urban heat island, and you can go anywhere using this app, go anywhere in the world and see this using the data. So this is Bangalore. You can see there are some hot spots, some cold spots. And if you see, the cold spots are over the green spaces in the city, and the hot spots are over the urban spaces. And you can see how the temperature differs. If you see a summer temperature, some places are up to 3 or 4 degrees higher than non-urban spaces. And understanding this phenomenon is very useful in saying, what can we do to make our cities cooler? How can we mitigate this effect using some of the solutions? So this is an example of using the data, scientific data, to understand this phenomenon. But once you understand what next, what can you do to fix this? And I want to show you the story about Tokyo, where Tokyo Olympics were happening, and they were really concerned. Tokyo is one of the cities having the worst effect of the urban heat island. The city temperatures can be as high as 6 degrees more than the rural areas. And this was concerning as the Olympics were taking place. So they said, can we use geospatial science and can use the understanding of the cities to mitigate this? So this is a story that shows you what happens. You can see the Tokyo temperatures are rising much faster than the rest of Japan and the rest of the world. And this is a concern that needed to be addressed. So first, they need to understand what's happening. So again, if you look at the temperatures in the city, you can see they are much more higher than the suburbs where the green spaces are. So one of the things that they discovered was that wind movement is really important, where the wind actually helps you cool down the city. But then there are buildings that were on the path of the wind that were blocking the wind and creating those, trapping that heat in the city. And by using this geospatial analysis, they figured out that there are a couple of buildings, tall buildings, they are the key in blocking those wind tunnels. So they actually demolished those buildings, moved those to the other places, and created this clear channel for the wind to pass through. And that helped reduce, increase the airflow and reduce the temperatures. They also started greening the city. So you can see now these are the railway tracks. They started planting urban gardens because the green spaces would actually cool down the city. So again, it's a very dense city. They don't have space. We also complain that we don't have space for gardens, but you can make innovative uses of the spaces that are existing to create green spaces around that. They also said that the urban road surfaces are also causes of trapping heat. So there are now heat blocking surfaces, where those are the surfaces which don't heat up as much as concrete, and they resurface some of the roads, and you can see that reduce the heat in the cities. Also, the stadiums where the spectators were going to watch those events from, they improved the air circulation using this innovative wind structures, which help the circulation of the air. So as you saw, geoscience should not be used in isolation. It's a multidisciplinary field. To solve a problem, you not only need physics, but you also need the support of geography. And this is what my message is, that by being curious, by asking questions, by leveraging the data that you already have and working together with other disciplines, you can solve a lot of interesting problems today. So I'm going to end my presentation here with this message. Be curious, ask questions, and solve problems. So curiosity is the most important one. Don't say, I'm curious about this, but should I learn things that are not in my textbook or not in my curriculum? Believe me, doing that will open up your mind. It'll help you become better at whatever you do. There are counterexamples of curiosity that was not related to my studies that helped me think about a problem in a different way, help me get a better job, and it'll help you become a better person to solve the problem. So with that, I want to end it. I will look at any questions If you can, if Gurudatta or Jayamam, you can relate some of the questions that were there asked, I can answer those.
So Ujjwal, there's one question. The question is, does Google Earth show real-time images?
Yeah, so I addressed it in the talk. Basically, it's not possible to show real-time images because there is, when the satellite captures it, there's a processing that needs to happen before the image is suitable for publishing. And even after the images are suitable for publishing, it takes a while for them to be loaded onto Earth. So typically there is, at least if you really tried, you could do this, publish an image few days after they're captured. During crisis, Google actually makes the effort to publish the images much faster. So after, say, an earthquake happens, they would capture, they would source an image from a satellite, publish it within 24 hours. But that's the fastest you could do. But most images in Google Earth are typically month to years old.
Okay, thanks, Ujjwal. Yeah, so I guess Nagajothi can take over.
Yes. Good afternoon, everybody. I would be covering about some of the technologies which is being used in this geoscience, and how it enables the mankind to get benefited out of this geoscience and the technologies. Basically, I'm working as a scientist in ISRO, and you all must be aware that ISRO is engaged in launching rockets and satellites for remote sensing as well as communication. So in addition, we also involve ourselves in generating various methodologies and applications related to geoscience field. So which I would be showing few examples. Of course, the applications are plenty, are numerous. So I would be covering only few examples just to show how effective this geoscience domain is. Okay, when we talk about geospatial technology, this is the technology relating to collection or processing of data that is associated with the location. So here we are mostly pointing on the location. So three major technologies in this. One is the remote sensing, wherein we try to collect the data of the Earth objects. The Earth objects could be either land surface or the ocean. So we try to collect the data using a device without coming into contact to the objects. So that is called the remote sensing. So that means we are remotely observing the objects and trying to characterize and study about the objects. The second technology is the global positioning system, which is GPS, which I think we are very well aware of it, and we are using it in our day-to-day life to navigate our cars or vehicles, or it helps the Swiggy or Zomato people to arrive to our place to deliver the material. So this is the system where it gives the location of any position in the entire globe in the day and night. Okay. The third one is the geographic information system. This is basically a computer software which helps us to integrate the data which we collect from remote sensing or GPS or any other field measurements, and use it to analysis and come out with some decision support. I mean, it acts as a decision support. It also helps us to come out with some strategic decisions. It could be in the country level, or it could be in the throughout the globe, or it could be in the Gram Panchayat level kind of information can be generated out of this software tool. So basically, in the remote sensing, what we are trying to do is the Earth objects. These Earth objects react to the electromagnetic energy which is falling on it. Okay, so when I talk about electromagnetic energy, so here it is the energy emanating from the sun. So sun acts as a source for electromagnetic energy. This energy is falling on all the Earth objects, whether it is on the land or the water, and these objects behave differently on different wavelengths. Okay, so some objects reflect the energy, some objects totally absorb it, some objects also emit the energy. So this energy we are trying to capture by putting a sensor on board. Okay, so this sensor, in the sense which collects the electromagnetic energy emanating from the Earth surface objects and records it. Okay, so these sensors can be mounted on the satellite or on the aircraft or on the unmanned aerial vehicle like drones and all to collect the data. So since daytime, that is when sunlight is available, so we call it as a passive remote sensing. So what happens when you want to collect the data during night time, or when the cloud is there, when the surface is covered by the cloud? So in these cases, we can generate our own energy, okay, using an instrument fit on the satellite, So that instrument will emanate the energy from the satellite, and it will reflect that energy to the Earth objects, and again collect back the reflected energy. So that is called the active remote sensing. Of course, this active remote sensing is used in some of our remote sensing applications, especially in the agricultural sector, to find out to monitor the crop and its growth and its yield and all those things. So as I told you, ISRO is engaged in launching satellites for communication and meteorology, as well as for remote sensing. If we see at present the scenario, India has one of the largest constellation of remote sensing satellites. Okay, so we have around 13 satellites in operation as on today. So all these satellites are used for some or the other applications in the geoscience area. Okay, so why this geoscience has become popular? Because of the advancement in information and communication technology. So using the computer-based software as well as the electronic instruments, in the sense the advancement in the sensing devices, we are able to now capture the finite information of the Earth objects, which is the size of the objects could be even 30 centimeter or even 25 centimeter by 25 centimeter. So we are in a position to capture the information about the objects of such small sizes also. Okay, so if you see, these satellites are placed in orbits around the globe. Okay, so the remote sensing satellites are mostly put on the near polar satellite. That means the satellite will orbit from North Pole to South Pole. Okay, the height of these remote sensing satellites are typically from 300 kilometers to 1,000 kilometers. So depending on the purpose, these satellites are positioned above the Earth objects. The second one is the geostationary orbit, okay, which is around 36,000 kilometers above the Earth's surface. These satellites are mostly used for communication and meteorology. Of course, all our DTH and other telephone connections are facilitated through this geostationary satellites. The advantage of this orbit is, once you place the satellite in 36,000 kilometers, the orbital period, that means the time it takes to make one revolution of the Earth by the satellite, is exactly 24 hours. So that means it is synchronizing with the rotation of the Earth, so that once you place the orbit satellite in this orbit, it looks stationary. That means if you view from India upwards, the satellite is always available to you. So that's why this is used for mainly the communication purposes. The third one is what the orbits used by our GPS satellites. Okay, so this is typically around 20,400 kilometers from the Earth's surface. Of course, this is a constellation of satellites. The details you can go through the website. So how these GPS satellites help in obtaining the position of one's position on the Earth's surface. See, when the satellite revolves on the polar orbit from North Pole to South Pole, South Pole to North Pole, it covers certain area on the Earth's surface. So that is called the swath. It is like, we are using our handheld camera or mobile phone to capture a picture. So we will be focusing on some area of the objects. So that area on the Earth's surface, it is called the swath. So this swath differs from sensor to sensor. Based on depending on the application, the swath is designed and it is used. So this is how the satellite revolves around the Earth's surface. Okay, you can see on the left side is a typical camera which is mounted on the satellites. Here you can see some 4 cameras. Okay, the thing is here, the ultramatic energy is the ultramatic spectrum. Okay, so it is ranging from gamma rays to microwave radio waves. So in this case, the advantage of using sensors is we can split the electromagnetic spectrum into different spectral wavelengths. Okay, it can be in within the red region or green region, blue region, and all those things. Accordingly, you can design the filters. So only the energy emanating from or energy reflected by the Earth object on that particular wavelength only can be captured by the sensor. Okay, so this has got different advantages. One major advantage is our naked eye cannot see the ranges beyond the visible. Whereas once you design the sensor, you can even capture the energy in the microwave or radio regions or infrared regions. I think you would have seen the CCTV cameras, which even records the images in the night time using infrared waves. So the advantage of using sensors is this: we can even capture the data which we cannot see using our eye. Okay, So the bottom side is a typical satellite, okay, wherein typical camera is mounted. You can mount several cameras, with several sensors for different purposes. So in this case, we have one color camera called list 3 and another black and white camera called pan camera. Okay, so this is how the camera is mounted on the satellite and launched. So in summary, what we do in remote sensing, the electromagnetic energy coming from the sun is reaching the Earth surface objects, and the Earth surface objects are reacting to this electromagnetic energy. Okay, and whatever energy is reflected back is captured by the sensor mounted on the satellite. The satellite records the data and sends the data to the ground station. Okay, typically in the ground station, of course, for Indian satellites, we receive the data in NRSC Hyderabad. Okay, Hyderabad, we have got a ground station. We receive the remote sensing satellite data there. Once the data is received and it is put it in the archival and given to the users in the sense, anybody, any common person or any department people can acquire this image, analyze it, and they can generate the information to their according suiting to their need. So what are the advantages of placing the sensor on the satellite? Okay, one is the synaptic view. You can cover the larger area. So unlike if you place the sensor on the aircraft or drone, you'll be able to cover only a few meters or few kilometers wide area. Where in the satellite, you will be able to cover the large area at a time. For example, we have one satellite which covers the entire Indian region within 2 days. I mean, within 2 passes, it will be able to cover the entire Indian region. And another thing is, you can get the data about the Earth objects which are inaccessible by the human being. For example, Himalayan regions or the Western Ghats regions where you are not able to reach personally, you will be able to get the data using the sensors mounted on the satellite. Okay, now what are the different kind of sensors, what data it provides from the satellite? It varies from 1 kilometer to even now 0.3 meters in the sense. What it is called is the resolution. The resolution means the each point which covers the certain area on the ground surface. That means if I say 1 kilometer area by 1 kilometer on the Earth surface is represented as a single dot in our picture. Okay. Similarly, we can go up to 360 meters, 190 meters, like that. You can go up to 0.3 meters of size objects also can be captured using this sensor. So this is called the spatial resolution. Of course, initially we were having satellites with 1 kilometer. Later on, the sensor technology improved. Now we are in a position to, the Indian satellites are in a position to capture the objects of size 30 centimeter by 30 centimeter. Of course, some satellites are even able to capture the nameplate, capture and read the nameplate of the cars also. Okay. So what is the advantage once you capture the image? Within a single image, you can generate a lot of information. You can study about the agriculture, you can study about the urban area, you can study about the groundwater, okay? You can study about the ocean surfaces. All these things are possible with a single image. So this is the advantage of recording the data in the digital form.
Global coverage.
Yeah.
IRS satellites.
I hope the video is visible. So this is how the satellite covers the area on the Earth surface
and the orbit altitude in order to revisit a specific area within the repetitivity cycle.
So each time it covers certain area on the ground surface. When it passes through when it orbits around the next cycle, already the Earth is also rotating. So it moves to a certain kilometer towards west and it covers another area. So there is a gap between two coverages, which will be covered on the next day. If you can see here.
5 days with 140 kilometers swap camera. Oceans at 2 camera swap covers 100 kilometers with a repetitivity cycle of 2 days. Video shows the global coverage from oceans at 2.
So the second day it covers the area which is left out on the first day. So like this, it will covers the entire globe, and it is called the repeativity cycle. So how oftenly you capture the entire globe surface, it varies from satellite to satellite depending on the swath. Some satellites cover within 2 days the entire globe. Some satellites take even 24 days to cover the entire globe. So that is how the data is captured. So now we'll see some few of the applications where this satellite remote sensing is used. So one of the major beneficiary is the agriculture sector. Okay. So here the information on crop statistics, which is required for planning and decision making purposes, such as distribution and storage of food grains, government policies, pricing, procurement and food security, etc., etc. These are all required by the Ministry of Agriculture and Farmers Welfare. So they use this remote sensing data very effectively. Of course, we from ISRO also provide a lot of information to this ministry regarding the crop and other agricultural plantations. So which helps them in coming out with the strategic decisions, which crop, where to store the food grains, or whether to export the food grains, or whether to import the food grains. That kind of policy decisions are taken based on the inputs given by this application. Okay. And it also uses, it addresses the many critical aspects like crop area estimation, crop yield, production estimation, and crop condition, etc., etc. Because we are able to capture the same area in different time period. For example, the growth progress of wheat crops. Okay, with the help of time series IRS data has been carried out from mid-November onwards, how the crop is growing and what is the condition of this growth, and what would be the production and yield of this growth, all can be studied using this temporal data. This is very much useful. Now the government of India is operationally using this technology to estimate the crop yield and production for major food crops like rice, wheat, groundnut, etc. So I was telling about the resolution. Okay, so why this resolution is important? So depending on your study area, suppose if you want to study for the entire state, and the data volume, if you take the 30 centimeter data, it will be very huge and it will take a lot of computation time. So in that case, if you want to study for the entire state, you can go for the coarse resolution, say 56 meter or above. So which will cover the entire state in one image. You will be able to derive information for the entire state. Or if you want to move to the district level or taluk level, you can always prefer to take the higher resolution data, let us say 24 meter or 6 meter, and still you can go further and you can get the information what is available on the field level also. Okay, using the resolution of 6 meter or 2.5 meter or 1 meter or 0.5 meter, etc. So in the sense, depending on your study area, you will be in a position to choose the with the available resolutions of any of the sensors. So next thing is studying the agricultural drought. Okay, this study is being carried out for every month by our department, and it is provided to the ministry. You will be able to find out the vegetation vigor in the entire country, where and all the vegetation is good condition, and where and all the land is not used for agriculture, and where the vegetation is not available, and what is the condition, whether any chances of occurring drought in that place. The third one is the forest. Okay, so forest department is, as I told you, forest, most of the areas are inaccessible, and whenever the forest fire happens, they have to identify where it is happening, how to reach that location, how to come out of that problem. In these situations, satellite remote sensing helps in very much in identifying the locations where and all the forest area is available, and where and the forest fires happen. And these things are operationally done by our department. Okay, so in addition to that, you can also know about the wetlands, forest and biomass mapping, land degradation and desertification process also is possible using the remote sensing. Now coming to the applications on the city level, you have seen the fascinating view the Google Earth gives about the Eiffel Tower or our Indian cities. So with the kind of resolution available, you can even able to mark the boundary of each of the buildings in our city area. So here I have shown one example of the Elichinelli ward within the Bangalore city, wherein you are able to find out the extent of each of the plot boundaries, in the sense the building footprints, it can be monitored. So where it is useful. Okay, so this is useful. This can be linked with the tax database. Okay, who and all paid the tax, whether they paid the tax according to the size of the building or the area which is covered, or the number of floors, whether it is apartment or whether it is a commercial building. So all those information can be related to this remote sensing derived information, and you can also find out whether any anomalies are there. Accordingly, you can go to the particular location, find out and correct it. And this is a typical example. As I told you, this satellite data is can be captured in various time frame, right? So we have the earliest satellite data. No, it's not actually satellite data. It is captured from the aircraft. That is called the Corona image, which was captured in 1965 the U.S.A. agencies, and it is available free to us to use it. So using this data, we have studied how many lakes were there in those days in 1965, and what is the condition of lakes in 2017 using the recent satellite data. So using this within the Bangalore region, we are able to find out how many lakes have vanished and how many lakes are already in the endangered condition, and which are the lakes which the reclamation has to be has to be taken out. So this study was very much useful to find out the kind of water resources available within the city limit. Similarly, the 3D city buildings, of course, you have seen using the Google Earth engine, you can see the 3D city, you can generate the 3D city model using the satellite data by capturing the images in 2 different angles. And also you can generate digital elevation model, which helps in identifying the, in simulating the flood scenario. For example, once you have the height information and you can simulate the flood scenario, and you can identify which are the areas which can be affected by the flood and the amount of rainfall. Okay. Similarly, this is used in geology also. As I have shown you earlier, you can identify the fault, fracture, and all those things. You can identify the condition of the rocks, and also the groundwater potential can be generated using this satellite data. Now, the land resources are very, very important. Of course, the land is used by human beings for various purposes, even for agriculture or built-up area or whatever it is. So monitoring this land resources is very, very, very essential. Okay. So this also we are carrying out every year. Okay, to identify what are the features available on the land surface, and what part the land is put to use by the human beings. So this helps to monitor as well as to manage the natural resources. When I talked about the natural resources, it can be land or it can be even water also. And we are not restricting our now study or data collection to land alone. Okay, so this data can be collected over oceans also. Ocean studies are very, very helpful, as it was told to you earlier, to find out the wind directions, the cloud movement, cyclone prediction, earthquake prediction, tsunami prediction, etc. So we have dedicated satellites. For example, Ocean 2, SAREL, and SCATSAT. These are some dedicated satellites specifically designed for oceanographic observations. And not only that, we derive several other related information like photosynthetically active radiation, ocean primary protection, total suspended sediments, suspended sediment concentration, etc. from this data. Okay. One typical example which I want to show you is the fishermen are going to deep sea to catch the fishes, and we support them by providing the information which location is ideal for the fish catch. Okay, so to increase the fish catch, we derive information using the satellite from the ocean surfaces. Like chlorophyll images generated from the satellite data. We also study the sea surface temperatures and relate this information with respect to the abundance of fish in the ocean. Okay, so we generate this information every day and identify the potential fishing area, give this location to the fisherman. So now this information is generated every day by the dedicated center called Indian National Center for Ocean Information Service, that is called INCOIS, located in Hyderabad. They pass on this information to all the fish landing centers in the Indian coast. So right now 586 fish landing centers are provided with this information. Okay. And weather and climate is an important component. So ISRO has established around 1,158 automatic weather stations to collect the data about the rainfall, wind speed, wind direction, etc. So which is used to forecast the weather and also to study about the weather conditions. So that's all about the remote sensing. I have shown you that few examples, and the second one is the global positioning system. This, I think you people are very much familiar the locations within and around the Indian region. The third one is the geography information system. As I told you, the whatever information collected from the remote sensing data, from global positioning system and the field data, which all can be integrated using this software tool, okay, which helps us to generate a lot of information by integrating this various data collected from other sources. So, for example, one can stand in a position and find out. So, what are the parcels within the half a mile of my location? That means what are the, let us say, what are the banks available within the half a kilometer region, or what are the hotels available? This kind of analysis are possible with geographic information system. Of course, this is one example. And if we just talk about the applications of GIS, it is up to the imagination of any human. Okay, so many applications are possible in this geographic information system. So all this can be combined, and what we are using in our mobile phone is called the location-based services. Okay, so here we are using the potential of GIS, GPS, wireless technology, internet, and smartphone. Right, the combination of all these technologies to help us where I am, what is nearby. Okay, all those answers are provided by these location-based services. Now, I talked about the several applications related to agriculture, forestry, water resources, etc. So, how to disseminate the information to the citizens or to any of the department people? So, we have a portal like Google Earth. Of course, in this portal, we restrict our data to only the Indian region. The portal is bhuvan.nrsc.gov.in. You people can visit this portal, and whatever applications we have carried out till date from the beginning. In addition, we also allow the people to download the satellite data freely from this website. Kindly go through this website. A lot of information is available in this website. Okay, so as I told you, here we just cover only the Indian region and the application related to the Indian nation. Now, finally, coming to the topic of your interest, what is this geoscience and how it is helped by the academic, okay, as a career growth. So this field is called the geoinformatics. It is a multidisciplinary field, and it covers the various aspects of geology, geography, and informatics. When I talk about informatics, it is basically the computer science and the communication technologies. Okay, the GIS professionals generally use the appropriate technology to map the digital data and then derive information out of the compiled data. Of course, now the few colleges are offering the bachelor's degree in geoinformatics. Otherwise, one can take up the graduation in any of the other subjects like geography, geology, or environmental science, chemistry, or physics, or computer science, and then take up the postgraduate degree in the form of either diploma, postgraduate diploma, or MTech in remote sensing, or MTech in geoinformatics, or MSc in geoinformatics. So these are the subjects offered by many of the universities within our country. Okay. So there are a number of government grants also available in the form of scholarships or stipend for the candidates pursuing master's degree or PhD degree in this field. So once you choose this career, so what is the scope for job opportunity? You can work in Ministry of Defense, Ministry of Environment and Forest, or the departments related to climate change like IMD, etc. And also you can work with the departments dealing with natural resources management, Indian Agricultural Research Institute, or Meteorological Department. And these are some of the departments which are the major recruiters for this field. And in addition to that, every state, they have their own urban development authorities. As I informed you, urban is one of the major discipline where the remote sensing is used effectively. So one can join some of these departments. Or if you are specialized or interested in some of the space-related applications of geoinformatics, you get job opportunities in organizations like ISRO or different space. Every state has got a state remote sensing application centers. You can get into there in addition to aviation centers. Yeah, so that's all. Thank you.
And Nagajothi sir, thank you for your presentation. Chandra Shekhar sir, would you like to open the floor for Q&A?
Sure, please go ahead.
Yes, audience, do you have any questions and queries you want to clarify with all our speakers? You can post it in Q&A. Also, you can use the chat window. I see a lot of discussions is happening on the chat window. If you want to speak directly with the speakers, then please raise your hand and the administrator, the admin will unmute you and you can post your question.
Nagajothi sir, thanks a lot for the kind of information which you have shared. There's so much more to know, and I'm really interested in getting our kids to see and have plan a visit. Do let us know if it is possible. And meanwhile, I would also like to ask you, as far as ISRO satellites are concerned, I want to know so much of especially critical data which is being taken by ISRO satellites, and there's critical data being even taken, defense data related data, or maybe nuclear plants related data, which is being taken by even all the satellites, US satellites. So how do we really take care that some of the sensitive data is not released or not used by these satellites and passed on to other agencies?
Yes, madam. You know that we only receive the data and we archive it, and sensitivity of that data is already decided which data is sensitive, which is not sensitive. So the data which is not sensitive only is provided to the public use. Okay, the sensitive data is already masked. Even within the data what we given to the public, if at all, if any sensitive area is there, that is masked in the satellite image and provided to the users. So that way the sensitive data is not at all revealed. It is kept within the department and it is available only for the specific users and for specific purpose. I hope you understand, because the defense related, of course, some of the satellites are specifically designed and flown for defense purpose only. From those satellites, even the ISRO will not receive the satellite data. Okay, defense people, they themselves have the ground station to receive the data for their own purposes. So that way the secrecy is maintained.
But then rest of the world's data, I mean, US satellites and other European satellites could still gather data based on the resolution they have, right?
Yes, yes, yes.
We can't mask those.
Yes. So there is some international space policy. So all the space agencies are supposed to obey the space policy. So based on that, whatever data captured by the other country satellite also, which they are not supposed to reveal. Of course, we don't have much control on other country space data providers. That's why, even in the Google Earth, you will be able to see what you cannot see from the Indian satellite data. You'll be able to see in the Google Earth.
Exactly, exactly.
That's why we have some issues which is not in our control.
Okay. Furthermore, I like to ask two things it opens up. One is that whether RTI can be applied on satellite data?
In the sense RTI, see, satellite data as such is available to the public, or one can purchase, or one can download free of data. You can have RTI on the applications or the information generated using that data. In the sense, what is the crop yield data available for this in this year, and what is the water level in the particular reservoir. This kind of RTA you can put it. Okay, not on the satellite data alone.
No, so I mean, so suppose there has been a case of industrial effluent being released to, and there has been issues with regard to people getting sick of the constant breaking laws of pollution norms. So yes, can that, yes, I mean, so then for those RTI is applied and all the data can be released based on the RTI, right?
Actually, the satellite data is captured on a particular day and kept as an archive. Okay, if you want information like this, for example, encroachment in the forest or encroachment in the government land within the city, so these kind of things, the information can be generated using the satellite data. And using RTA, you cannot ask straight away, just show me whether particular one of my land is encroached by anybody else or not. That way you cannot ask it. Only thing you can ask us to generate that kind of information, which may be on payment basis, right? you can ask for you can ask to generate that kind of information and take it.
Oh, so that means the individuals could ask and apply directly. There's an, or it has to be through the government.
Yes, yes, yes. No, if the information is already generated, available with us, you can ask.
I see. That's interesting. Thank you very much. And yeah, I just wanted to confirm that it's possible to have a visit arranged anytime with our students.
Madam, ISRO, every center has got an exhibition hall, okay, wherein all the satellite models and rocket models are displayed along with applications. So you can visit any of the ISRO centers. You can write to the public relation officer on the particular center. For example, in Bangalore, U.S.A, you can ask, or in ISRO headquarters, you can ask. They will give you the permission for you to come on a particular day, and somebody will engage you people by displaying videos, and somebody will explain you what other things are available. They will give you some handouts also. That way it is possible, but you have to get a prior permission. Depending on the busy schedule, they will allocate some timing for you, but it is possible.
Thank you, sir.
I just saw Chandra Shekhar, sir, you had raised your hand. You have any query?
Yeah, no, not a query. I just wanted to give some context to Deepika's questions. She has a group of amazing students, young kids, who do a lot of excellent geography work, and they present their work in our geography conferences every year. And one of the things they have, one batch of students learn is how to get use RTI to get data for their projects. So I think that's the context in which he's asking that question, which is simply amazing. Kids are able to do these things. That's all I just wanted to say. With
yeah, thank you, sir.
Sure.
I have a generic question to all speakers in today's webinar. The past month has been very, I wouldn't use the word interesting, but it has been very concerning that right from the climate summit happening that happened in Glasgow, and earlier this month, the impact we are seeing in northern India because of the burning of the crop patterns in Punjab, Haryana areas, and the smog and the smoke fire happening there. And in South India, with all this rain and flood happening, what is the thrust of geoscience education, and how would it help overcome all these things? I'm talking in the purview of, say, high school students, like how and what can they do, or what stream of study they can take, and so that eventually, say, 5 to 10 years from now, they can become some of the key decision makers of this country, the globe as a whole, and maybe start, taking steps to prevent such things.
Well, my feeling is that whatever education they're getting now is confined to the textbooks. Get them out of the textbooks also. And that, unless that happens, I don't see any potential for them to right away come to any kind of grips with this goings on. They may develop that later on, but if you want them to get involved right now and say, at least just become curious and wonder about what could be done, that would be a seriously empowering kind of education. The system as it exists does not allow for that. I think there are non-state players who could perhaps help in this, which is a good time for me to also mention that Mr. Gurudatta and I are working on developing a geoinformatics course for high school children, specifically for high school children, to be offered next summer. So these kinds of things, I think, along with imparting core disciplinary principles and technological tools for those principles, it's also important that children learn certain, I want to say, ethical concerns. One of the things that I think should accompany such education is to show children, to help them understand that my benefit, my progress is tied to the progress of others also. I cannot progress only by myself. Progress cannot be just for myself. And that value system also has to go with this kind of education. And I think the kinds of stories that we have heard today from Ujaval and the kinds of technologies and techniques that Nagajothi has shared with us, these are all fantastic things that children can and should be exploring. And I'm hoping that they become very involved in reaching high school children also, because there's a certain different level at which we need to operate. And it can be done. And I think it can be done.
Yeah, I can give, so I agree with Dr. Balachandran that it's taking the action on these issues. These are kind of complex, large issues involving multiple stakeholders. So addressing them at the high school level, again, I'm glad to hear that they're having access to tools like RTI, which they can apply to get some information. But again, I want to emphasize the multidisciplinary approach, that all these big problems require not only geoscience or physics, chemistry, biology, but also kind of communication, managing stakeholders, and a multidisciplinary approach. One example that I would like to say on what private players can do. There's a lot of emphasis on government should address this, but what private players and companies can do. We saw that the big problems about the crop burning in North India, which is one of the causes of the smog that's affecting. Now, what can you do? And there are people who are trying to develop solutions. The government, Indian Agriculture Research Institute, they developed a decomposer spray that you can spray that on the crops instead of burning, and that that helps you avoid the burning. Now, taking this to the farmer, that's a very complex logistical challenge. Who will pay for that? Who will monitor that? So there's a startup by one of my ex-colleagues at Google. They came up with this idea of partnering with some of the companies who want to, who can distribute this, who can help farmers apply this, and they use satellite technologies to monitor, where they say, did they really apply it, or did they burn their farm? The crop, and if they didn't burn the crop, they would get that compensation from saying that you didn't burn the crop, so you do this. So again, there are private companies that can help build that supply chain and the last mile connectivity. But again, there's a technology piece which is about monitoring. There's a technology piece about developing this chemical solution, but there's also a social piece about how to get to the farmers, how do you make them comply, how do I get the funding to do this. So again, there are solutions that can exist, and again, it can come from various sources, not just geoscience. So again, there are creative solutions that can be done both by private entities as well as government.
Yes, I feel it's very much necessary that all of this, what we are putting across in this one webinar, is sort of trickle down so that high school students, I say high school students, but in general, I also in the chat window, I had put a comment that everyone who uses a smartphone is a user of GIS-enabled technology today. But however, school children in particular, if they get to know how all this disciplines evolve and what is the scope, because with IT technology getting its way into all these domains, it has sort of created multitude of opportunities. And as far as I can connect from my professional experience, it is very difficult to find students or even young professionals coming into the domain who can get a good grasp on all these things. There is, by one estimate right now, entire India, the workforce in the geospatial sector is just over 3.5 lakh people. That's it. And earlier this year, Government of India has done a lot of policy framework relaxations as far as geospatial domain is concerned, and they want to target a 10-fold increase in the workforce by the end of this decade. So I feel there is a lot of trust that has to be given at the academic level to encourage more and more students to embrace this domain. One more point I also have to remark here is in 2015, the United Nations adopted this goal on sustainable development. They set a target of 2030 and 17 major target zones. And in their preamble, they have given a lot of emphasis on geospatial data and geospatial technology. So I feel a lot has to be done at the grassroots level of imbibing geospatial know-how, geoscience know-how amongst the students, so that eventually as they proceed to their higher studies and eventually end up as academicians or professionals, they can be more actively involved in this domain.
To add, Gurudatta, now the agricultural sector, the agricultural insurance is one of the major beneficiaries of this remote sensing inputs. So most of the private companies who are engaged in agricultural insurance, they take the services of some institutions or companies to map the crop condition as well as the damages happened, assess the area. Accordingly, they provide the insurance. So this policy is already being implemented and it is in force. Even the government sector is taking inputs from the remote sensing because agricultural insurance is one of the, I don't know, it is a business attractive sector, something like that.
Okay. Any more questions from the audience? Okay. In that case, I think we have reached to the fag end of today's webinar. I would request for concluding remarks from our chapter mentor, Professor Daya Sagar, who is a professor of Indian Statistical Institute, Bangalore, and is also the founder and advisor of IEEE Geoscience and Remote Sensing section of Bangalore. Daya sir, please add your concluding remarks.
Yeah, good afternoon, everyone. And this is a wonderful session. And actually, suddenly it struck me that there is an event that IEEE-GRSS chapter is Bangalore chapter is organizing. And then quickly I realized and I logged in, and then actually I was enjoying as an audience, as a participant. But suddenly one of the organizers penalized me to give a concluding remarks. But it's a real challenge for all the organizers, and never before, and whenever there is a technical talk, and we never used to get so many questions. And but today I have been seeing that there are many questions. It's a great thing. I think even IEEE is encouraging the chapters and sections to somehow take these many of these things like to the student level, at the school level. I think that is where we can really, encourage the young minds to look at the different types of topics. Like all the three talks were really very good, and then they are really, there's a popular talks by Professor Chandra Shekhar and my good friends Ujaval Gandhi, and then Nagajothi. And it's so some of the people, they have been asking, see, because mathematics, they say it is a queen of science, and where to use mathematics, many people have interest the moment we show the mathematics involvement in either geography and geoscience. And I think we can, bring more people into these domains. And so mathematics is indeed the part of geography and geosciences right now. And I can say that many policies, somebody is asking a question, and so how do you handle the policies? Yes, and spatial policies, now spatial social policies were well handled by using, the spatial data and of course the relevant mathematics. I think with all that, all the three talks were really remarkable. And this is just a beginning. I have been requesting the Professor Jaya Nair to keep organizing this kind of events as often as possible, because the student involvement and the developing young minds and nurturing young minds is really a big challenge. And now, of course, the present generation school students are very brilliant, and they can catch the issues very fast. So there is other question like teachers, of course, and I can see that the moment teachers, actually the teachers can interact with the chapters, and probably the Bangalore section GRSS chapter can initiate something exclusively for teachers. through the teachers, I think if they really insist, I think we can go like, caravans. We can go to some selected schools and then let the schools invite other students and other school students and other school teachers, and so that we can really talk and what are the benefits that they get by attending some of these IEEE webinars, and we can make it even more frequent. So these events, and we have so the wonderful initiative, another initiative is the Bhumandal Talk series, and I think we should allow and we should request the school teachers and the students also to attend Bhumandal Talk series. Though they are a bit more technical, but they can understand that there is something behind, and so that develops a kind of curiosity in young minds. So some of the questions actually Gurudatta asked to the other panelists was about they are the things actually our Indian science academies to handle, and they have been handling, and so some of the the issues like rift between governments and the policy makers, that's always there. And it reminds me, his question reminds me, and there was a nice document submitted to the government of UK. This was about 15 years ago by Royal Society of London about the climate change, and they have been actually talking about how to reduce the carbon emissions. And they are telling that because of these industries, the carbon emissions have been increasing, and in turn there is a lot of global the climate change. And for that, the answer from the government of UK, the Prime Minister was no. So the blatant truth is the economics. And the moment you talk about closing down these industries which are rampantly emitting the carbons, and we lose a lot of the finances, and so that is where convincing the governments is a big challenge. And at the most, we scientists and engineers can provide nice policies for the governments, but convincing governments probably through like conference recently held by United Nations. I think that is where these are the platforms that the young children they have really asked wonderful questions at different levels. I know that it is a concluding remarks. Let me not talk about these things. And so at the end, probably let me thank on behalf of IEEE-GRSS Bangalore chapter. And first, I should thank Professor Jaya Nair and Gurudatta, Nagajothi, and Shyamlal, and these people, when we have given them the opportunity to run the chapter, and actually they have been doing much more than what we have actually expected. And so they are really very intuitive, and then they introduced many different initiatives. And so one of them is this particular STEM initiative, and the other one is Bhumandal Talk series. I think these events have to be actually popularized and publicized through different media like news letters and different news sections. I think so. This is a request, and please continue organizing these events. And from now onwards, I don't miss these events, and I missed several events before. But with all that, so I'm not sure. I think if had these talks been in-person mode, we should have actually honored all the speakers. But let us see a way, Professor Jaya, and whether we can call them in person and organize an event, including the school teachers. Probably now, I think you can plan within another 2-3 months, and so we can also see ISI is one place where you can organize the event, or in ISRO it is difficult, and or in IIIT it is possible. And make sure that all the speakers who have given talks through Bhumandal Talk series and through the STEM series, and we can bring all of them, and we can see whether we can support their travel. I think let me just thank first of all organizers and then speakers, and because someone should initiate, and even the questions that have come from many people, both teacher and student community, are really remarkable. And And so this is also a request to the teachers and students, and please keep attending these events. And we bring, the excellent speakers to deliver the talks, and they all, enlighten not just the teachers and children, and so they enlighten all of us. So thank you very much. And so Jaya, I think you can just say one final word.
Thanks, there, Sagar. I'll actually pass the baton to Shyamlal. So, yeah, thank you so much.
I thank Professor Dayasagar sir for giving the concluding remark on behalf of the IEEE-GRSS Bangalore's SLAT. I thank to also all the participants, all the student children, those who have today attended this webinar, make it very successful. And I'm happy that they also raise many questions. In short, I'll give thanks to all the my SLAT member also, and then mainly the speakers, Nagajothi sir, Ujaval sir, and Chandra Shekhar sir. Because of the three eminent speaker, it is also possible. If they would not help us, the event would not be possible in that way. Because finally, that very useful and important information has been transferred from the speaker to the young our children, which is most important. So one word finally, this is just beginning, not as a ending. We will do lot of new things for the new generation. We'll try to innovate them by new knowledge, new technologies, new tools, so that they can equip with the knowledge, lot of knowledge. Thank you all.